Tarun, what are we doing?
I can solve for. I can identify similarity, use scale factor, and find missing dimensions.
So all of these notes contain information on how to figure out similarity, use scale factor, which is the very end, and then calculate missing dimensions. Lots of vocab words, very, very key. Similar, the symbol for similar, right here. The similar for congruent, right here. You can read the definitions for them. You got to know those. It's got to be in your brains as of now. The definitions for similar and congruent angles and congruent sides. Corresponding, no symbol, you need to know it. Scale factor, you need to know it. Okay, what must you know? Who can read? Who can read us the must know very loudly, Taruna?
For two polygons to be similar, all corresponding angles must be congruent and corresponding sides must form ratios that are equivalent.
Okay, you gotta know this. You gotta think about this. We talked about it, you gotta think about it. This is something you have to know for the final test. So read through that and not only just read through it and say, yep, I read it and call it good, read through it and understand it. Think about everything it's telling you. We use tons of vocab words and that must know. Number 3 here, we have an example of similar figures. Using corresponding sides, we determined which of those 3 shapes were similar by using proportions, which we did in our last lesson, yes or no? Okay. So cross products, cross multiplication. Okay, so go through that, read through that. Number 7, we dealt with a word problem. Determined how to calculate, again, using algebra. How to set up a problem and then calculate a missing side. And then we use this exact same problem down on number 4 to deal with scale factor and keys to scale factor. Somebody tell me about scale factor, whether you're blowing something up or you're shrinking something down. Who can explain what the scale factor number has to do with it? Or what the number 1 has to do with scale factor and shrinking or enlarging? Madison.
If you're blowing something up, it has to be greater than 1, and if you're shrinking something, it has to be less.
So scale factor, perfect, Madison. Scale factor is essentially the number you are multiplying the dimensions by to determine the new dimensions of something that is being enlarged or something that is being shrunk. If it is greater than 1, it's going to be blown up. If it's less than 1, it's going to be shrunk. Yes or no? Okay, so scale factor can get confusing. How would you determine the scale factor? What are you using to determine what a scale factor is, Ahmed? Division of what? Division of a ratio. Okay. So you're using ratios, right? You're dividing the ratios. Ratios of what, though? What sides? Ratios of what sides? Yes or no?
Yes.
Okay, so you didn't pick that up in the video. You are using ratios of corresponding sides to determine scale factor. And again, if you want a scale factor of bigger than 1, or if you get a scale factor bigger than 1, you're blowing it up. If it's less than 1, you're shrinking it down. Does that make sense? All right, and then you do have an example here on number 8. Right here. What is the scale factor used to shrink down the width of the picture? Okay, so we have 2 pictures. We drew them out, which I strongly recommend you draw pictures. And then we use the corresponding sides, in this case, 1.5 and 10, to get a scale factor of 0.15. Would you get the exact same scale factor if you divided 2 and 1/10 and 14?
Yes.
It's going to be the same thing, because remember the corresponding sides, and we've already proven that these shapes are similar, because that's where we got our 2.1 measurement earlier on in problem number 7. Okay. Anything to add? Any questions before I shut down?